You go to send an email or stream a movie, maybe just look up a cat video. You click a button and boom! In literally less time than it takes to blink, your request has shot across the globe and back. How on earth does that happen? It really feels like magic, but it's not. It's an actual physical journey. And today, we're going to trace that journey right from your fingertips to the other side of the planet.
You know, we hear this term the cloud all the time, right? But the internet isn't some magical vapor floating up in the sky. It's a real physical system of wires and machines. So to really get it, we got to start small. I mean, really small, right inside your own home. And then we're going to zoom all the way out to see how the entire planet is wired together.
So, before we can even begin to understand the global internet, we have to start with the mini internet that you've got running right inside your house or your office. This is the absolute foundation for everything else.
This is what we call a local area network, or, LAN for short. Just think of it like your own personal digital bubble. It's got all your connected devices inside it. And you know what? Creating one is surprisingly simple.
At its very core, it really is this simple. You take your devices, your computer, your TV, your game console, whatever, and you connect them to a central hub. Now, back in the day, this was all done with actual physical cables plugged into a little box called a switch. Today, your Wi-Fi router usually does this job wirelessly. But the idea is exactly the same. You're creating a private club where all of your devices can talk to each other.
Okay, so how do they actually talk? Well, they send messages, but they break them up into these tiny little pieces called packets. The best way to think about a packet is like a digital envelope. Your computer writes it, sends it to the switch, and the switch acts like a super fast mail carrier, delivering it to the right device on your network.
But, and this is a big but, right now this network we've built is completely isolated. It's basically a digital island. All the computers can chat amongst themselves, but they have absolutely no idea that the outside world even exists. They can't get to Google, they can't get to Netflix, nothing.
So our little digital island is totally cut off. To connect it to the rest of the world, we need to build a bridge. And to do that, we need two really important pieces of gear.
It really all boils down to this. How do we get off the island? Well, to do that, you need two things. You need a door to the outside world, and you need a guide who actually knows the way. That door, that's your router. Its entire job is to be the gateway. It stands right at the edge of your private, local network, and it manages all the traffic going in and out to all the other networks.
And our guide? That is your internet service provider, your ISP. The company you pay every month for your internet connection. They're the ones who run the actual physical cables to your house and literally plug your router into the planet-spanning network that is the internet.
So here's the absolute key difference, the thing you've got to remember. The switch is for local chatter. It's connecting devices inside your house. The router is for global conversations. It's connecting your entire house to the rest of the world. Think of it like this. A switch handles internal mail, but a router, that handles international shipping. Okay, so our island now has a bridge to the mainland. We are officially connected. But what exactly have we connected to? Let's zoom way, way out and get a proper global view of this so-called network of networks.
If you take away just one single thing from all this, please make it this right here. The internet is not one big single thing. It is, quite simply, millions of private networks, just like the one in your home, all connected to each other through this massive tangled web of routers.
And it's a totally fair question. Why all this complexity? Wouldn't it be way simpler to just have one gigantic, super powerful router sitting somewhere in the middle of the world that everyone just plugs into? Well, it turns out that would be an absolute catastrophe. This spread-out design is just brilliant because it dodges a total disaster. Just think about it for a second. One central router for the entire planet. If that one machine breaks, poof, the entire internet just vanishes. Not to mention, it would be hopelessly overloaded by billions of devices. And can you even imagine the planetary-sized knot of cables all leading to one single spot? Instead, this web-like structure means there's no single point of failure. The internet is literally built to survive.
And this right here? This is all the proof you need that the internet is not a cloud. It is a physical marvel. There are over 4 million kilometers of fiber optic cables, enough to wrap around the Earth 100 times, just lying on the ocean floor. This is the real physical backbone of the internet, connecting entire continents at the speed of light.
So just how physical are we talking about here?
Well, get this. Back in 2007, sea pirates off the coast of Vietnam literally stole an 11-kilometer section of that undersea cable. They just chopped it out, disrupting service for millions of people just so they could sell it for scrap metal. It does not get more physical than that.
All right, so we have our home network, we've got our router, and we've got this incredible global web of cables. Now let's put it all together. Let's trace the amazing journey that happens every single time you do something as simple as clicking play on a video.
First things first, where is that video even coming from? It's stored on something called a server, and a server is really just a very powerful specialized computer. Its whole job is to hold on to content and serve it to anyone who asks for it. So when you go to a website, you're actually connecting to one of these real physical machines somewhere in a data center.
Okay, so here's the whole dance from start to finish. You click play. Your computer zaps a tiny request packet out the door. It leaves your house through your router, and then it hops across dozens of other routers all over the world, finds the exact right server and says, "Hey, send me that cat video." The server then immediately starts sending the video back to you, broken down into thousands of response packets that retrace the journey. And all of this happens in milliseconds. It's just wild.
And that, my friends, is streaming. You aren't downloading one giant movie file and waiting for an hour. No way! You're receiving a constant, high-speed delivery of thousands and thousands of tiny little packets, and each one arrives just in time to be played on your screen. It's an incredibly smart solution for moving huge amounts of data across the world almost instantly.
So there you have it. From your home network, out through your router, zipping across millions of kilometers of undersea cable to a server and all the way back again, all in the blink of an eye. That's the internet. It's not magic. It's this hidden, lightning-fast dance of data packets that powers our entire modern world. And it's still growing. It's still evolving. The only real question left is, what will this incredible network of networks connect next?